Okay. You can see now in today's session, we will see the different problems that we can have in module 3, that is second half. Before we move to the problems, the variety of problems, we will first look into what different problems we may expect on different concepts. So what all concepts we have studied in module 3, we will just recall. In the initial module 3, the first half we have already covered the Laplace's and Poisson's equation and its applications, which we have already covered. Even the problems also we have seen. Okay, now moving to the second half, we have seen, we started with Biot-savart's law. We have started with Biot-savart's law. Then we have seen what is Ampere's law. In short, I'm writing. Then some of the applications we have seen, applications of Ampere's law, some 5 applications we have seen. So this is one variety. This is Ampere's law, the second variety. And the third is curl. Okay, curl concept, and related to the curl, we have seen what is Stokes theorem. So the different possibility of questions, the problems will be either on Biot-savart's law, that is finding the magnetic field intensity H, or we can see for a small element it is DH. So this is one possibility. For Ampere's law, again we go for the line integral. HDL is equals to current I. So we will see in different problems how we can utilize this equation, and then applying the curl, that is a Stokes theorem, that is your Maxwell's equation del cross H equals to J. So related to finding the current density or H, so how to apply the curl, all these things we will be looking into. So let us start with the first variety, that is Biot-savart's law, or finding the magnetic field intensity. See, finding the magnetic field intensity H, or finding the magnetic flux density. Both may be possible because we know that B and H are related to each other. If the question is finding each of these, we can relate them. Find H and you can find B from that. Hope it is clear. Okay, let me read out the first problem. An infinitesimal length of, you can see the length, it is given 10 to the power of minus 3 meter wire. It is located at point 100. So you have one conductor. In that conductor, okay, it can be of any shape. In that, this conductor is divided into many smaller elements, okay, of infinitesimal length, means as small as possible. And that length, that is a DL, is given to you. One small part length is given to you, and it is located at point. So at point, which point it is located is given in the problem. And it carries a current of 2 amperes. So current value I is given to you in the direction of unit vector AX. See, it is very important. Direction of the unit vector is specified. Find the magnetic field intensity due to the current element. So it is not like we are finding the total field. Okay, it is we are finding the magnetic field intensity due to the small element. Fine. You can see what all things are given to you. I have not listed, but I have tried to put that in the form of a figure. This is your XYZ coordinate system, rectangular. If I assume you have, what is the given thing? It is in the direction of AX. So you have a current, whether current direction is specified to you in the question, just check it out. An infinitesimal length, it is located at point and it carries a current in the direction of AX. Yes, direction of current is specified. See, in positive AX direction, the current is flowing, and this value they have given it as 2 amperes. Then out of this, current is flowing in what? In some conductor. In that conductor, some small element length is given, and this small element is at point 100. So you can see here that small element I have considered, because if you see the coordinate system, divide this starts from 0 1. So 100 means x distance in 1 unit. You don't have y and z, so here I have taken that small element. Okay, hope it is clear to you. Try to understand the figure. Once you understand that, using the formula won't be that difficult to you. So hope you got this. This part I have drawn it. This is the small element location, and current is flowing in AX direction. Now we need to find the magnetic field intensity at what point. That point is specified as 0 to 2. So if I try to put 0 to 2, see 0 starts from here. You don't have any x travel. X unit is 0. Y and z is 2. So I will travel in y direction 2 units, and then z direction 2 units. So somewhere here I will get that point P. So what I need to do, I need to find what is the field, magnetic field intensity at this point. यहाँ पर DH value क्या होगा? So you can say DH subscript P at point P. What is the value? No need to find complete H, because it is due to that small element they have asked DH. And you can see, just recall Biot-savart's law. Obviously the question is based on Biot-savart's law, and let us recall that law, what it is. If there is an infinite conductor, if I take a small portion dl, okay, this is your dl, and see, this is your point P. I can draw a line joining here. This is your distance r, and in the same direction you have AR. Okay, at what point you want the field. So that is in AR, and you know what is DL. DL's unit vector is in this direction, up whatever line this you're considering, and this is the angle theta. Fine. So if I take that, you can see point is here, and the element is here. So the line joining is somewhere here. So that is AR. Okay. So I'm applying the Biot-savart's law concept to this particular problem. Now let us use the formula. So what is the formula? We know that at point P, we need to find this. So formula is DH is equals to IDL cross AR unit vector. That is the formula. Either you can use IDL sine theta divided by 2 pi r square, or this is the formula in vector form that we have already derived. So what all things are unknown to you? Current is given to you, I, that is 2 amperes. DL, length of that small element is also given to you, 4 pi. What is R? R square. You need R and you need AR. So these two things are unknown in the formula. You need to find R and AR. So let us start with these calculations. So if I take R value, how will you calculate R? R is what? The distance between that small element and the point. So line joining के बीच का distance R होगा, small r. So you can use the distance formula, square root of, what are the x coordinates? 1 and 0. Root of 1 minus 0 whole square plus y coordinate 0 minus 2, z coordinate 0 minus 2. So if I take that square root of, so I will get the magnitude of r. I have got it as 3. Now, how can you find the unit vector AR? So I have specified the direction here. So how to find the unit vector AR? You need to, you just remember from the basics of module 1, how we take the direction, initial minus final. Hope you remember that. So let us use the same concept here. If direction is in this way, let me take this as initial position, this as final position, final minus initial. So 0 minus 1 in x direction, 2 minus 0 in y direction, 2 minus 0 in z direction. So how can I get R, magnitude of this AR? I have taken R here, 0 minus 1, 2 minus 0, 2 minus 0. So I have got it as minus AX plus 2AY plus 2AZ. So this is what the position vector. Okay. So how can you find the unit vector? Unit vector is the position vector divided by its magnitude. So position vector we have found, magnitude also we have found. Take that ratio, you will get the value. So you can just further simplify this 1 by 3, 2 by 3 and 2 by 3. You can see the coefficient is -1, -1 by 3. Coefficient here it is 2 by 3 and again here also 2 by 3. Or else you can keep this simple as it is. So we have found what is magnitude and what is this AR. So both unknowns we have found. Now we can use the formula. So let us see how we can use the formula. See, DH is equals to ideal cross AR. Remember, this is not a multiplication, it's a cross product. Because two different vectors we are multiplying, we need to use the cross product. See, I current is 2. I have substituted. This cross is what? Simple multiplication. Okay. DL, the length of the element is 10 to the power of -3 meters they have given. So 2 into 10 raised to -3 is ideal value. In which direction? Because ideal completely, if you see, if you take this I separate and take DL, DL has to be a vector because हम cross product ले रहे हैं. When we take the cross product, we have to take two different vectors. So इसको भी हमको direction specify करना होगा. So what is the direction of DL? Just observe the figure. Suppose you can see this is what in which the current is flowing and a conductor is kept somewhere like this. If I consider this portion, small element, its direction is in this way. So that is nothing but AX direction. So ideal element, it is in AX direction. That's why while solving, I have taken here, it is AX direction. Okay. And see with the bold dark lines, I have specified this indicating it's a cross product. It's not a multiplication. Then AR we have found. What is that? AR, it is R divided by magnitude of R. Substitute that. Now, let me just give you one hint. How can we go for the cross product? One way is what? Simple. You go for multiplication of each term and see what is the answer. Or much simpler way is taking the determinant form. Suppose you have two vectors A cross B. Okay, you have A in all the three directions, X, Y, Z. That is AX, AY, AZ. Even B is also in three different directions, X, Y, Z. So how to get the cross product? How? First row of this determinant will be always the unit vectors, AX, AY, AZ. Second row is ये जो आपका first vector है, उस वेक्टर के कोएफिशिएंट्स को लिखना होगा. सपोज एग्जांपल A is say A vector is 2ax plus, I'm giving one example, 3ay plus 4az. Suppose A vector is defined in this way. So what are the coefficients? 2, 3 and 4. So second row should have this 2, 3, 4. I'm giving you a shortcut method how to find the cross product. Now B, suppose say B is 1ax, some example, plus 5ay. You don't have z term, okay? Only two different coordinates are specified, 1 and 5. So third row of your determinant includes coefficients. So here the coefficient is 1, here the coefficient is 5. So 1, 5, you don't have z, az, so put it as 0. So now you know how to calculate the determinant. Ax into bracket, this minus this, then a minus ay into bracket, these two terms minus these two terms, then plus az into this minus this. So you know how to simplify a determinant. So that would be much easier. Otherwise, what you generally do in order to get the cross product, you will take this multiplication with this ax cross ax, cross product of the same I dot I cross I is 0. Then you go for ax cross ay. Ax cross ay is the third unit vector az. Then ax cross az. So like that you do. No issues. Even you can follow that procedure also. Ultimately, you will be getting the same answer. This is one easy way to find the cross product. So that's why I'm giving this. So taking that determinant, you can see what all coefficients I have used. First row of the determinant is the unit vectors ax, ay, az. Observe the second row is what? Ideals coefficients. Ideal is what? 2 into 10 raised to minus 3 in ax direction. You don't have ay and az, only ax is there. That's why first value is 2 into 10 raised to minus 3. You don't have y and you don't have z, ay and az coefficient. So 0, 0. And what should be the third row? Third row is ये जो आपका AR है उसके coefficients third row में आएंगे. So what is that AR? AR is this minus 1 by 3, then 2 by 3. Here also it is 2 by 3. So that's what I have written, minus 1 by 3, 2 by 3, 2 by 3. You can solve this. Or else you follow the same, taking the multiplication, each term, see what is the unit vector and solve. No problem. So I have done it in this way. Further, if you solve, further is using the calculator. So I have got the determinant value, this. How to get that? Simplify that, ax into this minus this, 0. So you don't get any ax terms here. Then minus ay into these two multiplication minus these two multiplications, and then plus az into this cross this. So when you solve it, you will get this. And outside you can see you have 1 by 4 pi r square. R is 3, so 3 square. That it is kept outside. Further, if you simplify it, I have got, taking the multiplication and solving, both ay and az directions you will get for dh. And it is in a micro. See what is the unit of magnetic field intensity? I have written amperes per meter. That is the unit of magnetic field intensity. So this is the first problem. It's very simple. Just understanding, putting that in the form of a figure is very important to imagine the situation. So hope you understood this problem. Just let me know if any doubts are there. Else I will move to the next problem. Find the magnetic flux density. Magnetic flux density is capital B at the center of a square. So you have a square with you. Whatever conductor is there, it is put in the form of a square of sides equal to 5 meters. So side ka length diya hai, that is 5 meters, and it carries the current of 10 amperes. So current given is I equals to 10 amps. So this is the given thing. Any other information? No. So they have not specified where this square is placed in the space. So you have a complete freedom of choosing your own space. Okay. So let us recall this Biot-savart's law once. If this is your conductor, point P, and this is your line joining. If a tangent is drawn like this is the angle theta. So point P पे आप DH find कर रहे हैं. What is this DH? It is the magnetic field intensity due to this small element. Okay, and what will be the direction of your magnetic field intensity? We have seen in our theory classes how we determine the direction of the magnetic field intensity. If suppose the current is flowing in this direction, I had taken that example of a circle. If you put somewhere like this, the element is chosen. Try to remember field lines and all. We had tried at each point what is the value of the magnetic, what is the direction of the magnetic field. Okay, just recall that. Remember in the Biot-savart's law, how we find the magnetic field's direction is, one is that right hand rule. Okay, direction of current is much easier to predict there. Now remember, in whatever plane you consider your current element or your conductor, उस प्लेन के परपेंडिकुलर डायरेक्शन में आपका फील्ड रहेगा. और मैग्नेटिक फील्ड जिस प्लेन में रहेगी उसके परपेंडिकुलर प्लेन पे आपका कंडक्टर होगा, वाइस वर्सा. So perpendicularity is most important here. uh, keeping that as the base, now let us solve this problem. As I told you in the given problem, they have not specified you in which plane this conductor is placed. So you are free to choose your axis, ax, e axis, plural. Suppose you have these three coordinates. Obviously, ये जो आप loop use कर रहे हैं, square loop, which is given to you, your conductor, a straight conductor is bent, okay? It is bent and it is formed like this. So this loop is kept. Obviously, if loop hai, तो you cannot use all the three coordinates. Either this loop can be kept here or here or here. So you're free to choose your position of this loop. So observe this, what I have done here. This is the x direction, y direction. That's it. So from this is viewed from the top. Assume करो कि आप top से देख रहे हो, ये floor पे ऐसे loop है. So you are watching this from the top. Okay, and even they have not specified just magnitude of the current. They have given us 10 amperes. In which direction current is flowing, it is not given. So I'm assuming this, you can see I have assumed in anti-clockwise direction. You can choose your own directions, so that is not, you are free to choose, it is not specified in the problem. Okay, uh, one more data is given to you, 5 meters. So that is the length of each side of this square. Okay, actually conductor straight है, इसको square जैसे fold करके, okay, in the form of a square it is put. Now, how will you find the magnetic flux density? Flux density है या फिर magnetic field intensity? So obviously यहाँ पर हम Biot-Savart's law तो use नहीं करेंगे, not directly, but application we will be using. Try to remember, when we apply the Biot-Savart's law for a long straight conductor, infinite conductor, we had got a one equation, that is H is equals to, okay, hope your notes are there with you, I by 4 pi rho something, I guess, okay, in a phi direction. This we have already derived in the classes. This is what when the conductor is infinite. Suppose our conductor is of finite length. Okay, try to again remember, in the class we had taken three different situations. एक situation था, our conductor was something, it was put something like this. Finite length है, ये point A है, ये point B है. So this is your reference axis. So if I take this end, okay, whatever angle we measure is negative. Whatever the upward angle, whatever from this point B, the top end of this conductor, from there if we measure the angle, it is positive. Okay, ये एक situation है, sign conventions for the angles. Suppose my conductor is kept somewhere like this, then this is your reference axis, both will be in the negative. And suppose my conductor is something like this, point P is here, okay, then both angles are positive. So we have seen in our theory background, please recall the theory, it is important to solve the problems. So for three different conditions we have seen, conductor आप कैसे रखोगे उसके ऊपर आपका angle positive या negative होगा. So directly we are not using the Biot-Savart's law here, but application of Biot-Savart's law we are using. Okay, so hope you understood the figure first. Okay, just I have not explained any angles still, just what I have told you, एक conductor है जिसको fold करके एक square loop में form किया है. I have taken the corners as A, B, C, D for convenience, so that while calculating we will be knowing what we are doing. Then direction I have taken, the current is anti-clockwise direction, and we are free to choose our plane. So, and see, I have not kept the plane something here. Okay, I have not kept like this. I have kept it like this because it is easier for me. from the zero, because since it's a square, अगर length 5 मीटर है तो मुझे अगर bisect अगर मैं करूंगी इसको तो this will become 2.5 2.5. It would be much easier for me. That's why I have kept it like this. You're free to do like this also. Okay. Now what will be the total field? Let us first calculate what is H, then we can go for B. Now to find H total, okay, from the Biot-savart's law application, whatever H value we have got, just try to recall the formula. Formula is H equals to I by 4 pi r. If it is finite, sine alpha 2 minus sine alpha 1, some formula we have got. This is what it is, a total integration only. Okay, integration means हम यहाँ पर suppose एक side consider कर रहे हैं out of 4 sides. In one side again we have divided this into many smaller elements. Okay, while derivation also we have done that dz we had taken, remember. So these the smaller values we have integrated all together and एक conductor के लिए हमने ये H equation लाया है. Okay, but that is for one single line. But suppose यहाँ पर आप इस application में observe करोगे, this square is made of 4 such sides. So whatever H you calculate, no doubt it is the formula used is H equals to I by 4 pi r sine alpha 2 minus sine alpha 1. And जो भी आप एक side के लिए ये conductor करोगे, it is the same for all the remaining 3 sides. So H आपका जो भी आएगा एक side के लिए, you multiply that with 4 into H. Then you will get the total magnetic field intensity. Okay, hope you understood this, why we are multiplying our final answer with 4, because whatever calculation we are doing, it is for one single straight conductor. तो यहाँ पर square अगर है तो square has 4 different sides, so we have to multiply the answer by 4. Now let us solve this. Consider a square in xy plane. So for our convenience, we have taken it in xy plane. And first, whatever calculation we do it for this side, and the same we will extend for remaining 3. So multiplication. See, you have a center here. Since this side is of 5 meters, if you bisect it from this point, it is 2.5, 2.5 each. And this is 90 degrees. This is also 90 degrees. Now, your reference, where you need to find this flux density or H, B or H, it is at the center of the square. So, आपको यहाँ पर origin पर आपको find करना है H. Okay. So, ये आपका point P हो गया. At this point, you need to find. So, आपका reference axis ये है. Now, you can see reference axis. ये आपका लेंथ है, फाइनाइट लेंथ है, एक एंड कंडक्टर का पॉइंट ए है, एक एंड पॉइंट डी है. सो इफ यू कनेक्ट पॉइंट ए एंड दिस सेंटर, एंगल मेजरमेंट अल्फा 1 is negative, and if you see point D and this center point, if you connect, the angle measured is positive. So alpha 1 negative होगा, alpha 2 positive होगा. So alpha 1 is negative, alpha 2 is positive. Now how to find these alphas? For finding the alpha, we will go for trigonometric. We will make use of the trigonometric functions, sine, cos, tan. So how will you find this angle? This is your hypotenuse. Suppose I want this triangle. Okay, here it is 90 degrees. आपको ये angle चाहिए. How will you define sine theta or cos theta? अगर आपको sine चाहिए तो you take opposite by hypotenuse. Opposite is 2.5, hypotenuse we don't know what is it, and you can calculate actually. क्योंकि ये आपका base जो है even that is 2.5. So you can calculate this, right? Pythagoras theorem, 2.5 square plus 2.5 square equals to this OD square. And you can find what is OD, and you can use either sine theta or cos theta. Or आपके पास readily available है. This is also 2.5. This is also 2.5. So what is tan? Tan theta. Tan is sine theta by cos theta. So opposite by base. Opposite is 2.5, base is 2.5. Why to, go for Pythagoras theorem, finding the hypotenuse and then calculating this. So directly take 2.5 by 2.5. So if you do that, tan inverse of 2.5 by 2.5, we are calculating alpha 2, right? So alpha 2 is tan inverse of 2.5 by 2.5. So tan inverse of 1. Both sin and cos, I think both are equal at 45 degrees. Yes. So tan inverse of 1 is 45 degrees. Alpha 2 हमको 45 आ गया. And alpha 1 in the same line, try to calculate what is alpha 1. Alpha 1 भी आपको same ही आएगा, but negative आएगा. That is important. Measurement, you can see it is in negative direction. So in the same line, if you calculate alpha 1 and alpha 2 we have got. Now remaining is using the formula. So वो जो आपका square का side है, this vertical side, I by 4 pi r sin alpha 2 minus sin alpha 1. Alpha 2 and alpha 1 values we have found, and just apply what is sin 45. Sin 45 is 1 by root 2. Just check the values, substitute the values. I is given to you 10 amperes, 4 pi. The distance r is what? Yes. How to find r? What is r? R is, अगर आप ऐसे कंडक्टर लेते हो, this is your point P. Try to go for that theory. ये आपका point है, and ये आपका row distance है. Okay, this is the point P. From the point to this point, the distance is that rho or r. In the theory, we have studied this. So you can see here, इस point से इस point का distance क्या होगा? It is half of pi. That is 2.5. So it is, I have considered r as 2.5. So find what is h. H is, you calculate, simple आपको calculator use करना है. Find it. I have got it as 0.4501. That is h value, total value. Don't get confused. It is not ph. It is only h. Integration of one single this vertical line, vertical side. So it is amperes per meter. But formula में हमने जो भी use किया है, always we have used a phi direction. Remember, हम जो भी h का formula लिखते हैं, h equals to I by 4 pi r. A phi direction we specify. Okay. So a phi direction is there, but whatever we are dealing, it is all x, y, z, that is rectangular coordinate system. So we need to convert this. We need to find what is, equivalent. वो या ax होगा, ay है या az है.